Hey, in this one I wanted to show you how to do Python bindings for C++, a C++ library. So there is like lower levels way of doing this with like C types and so on, but in C++ there is this library called PyBind11, which is extremely nice because it gets rid of a lot of boilerplate for you. So let me show you how to use it. So I'm gonna kind of go very quickly over the installation. I'm just using CMake because it's kind of the standard, but they support some other stuff as well. You can feel free to just look at the documentation to see how to install it, but in the end, you will just have some kind of CPP file where you will define your bindings, so nothing crazy. So let's just go into this example.cpp, which will be my bindings file, and let's define a module. So you do this with pybind11 module, like so. You have to give a name to your module. So in my case, it is just example. And then you have to give it like a variable name. So this is how we will refer to it in C++. Then you do the curly brace, and then you can start defining a function for it, for example. So let's create a function add. We need to give the function as a pointer, like so. And then we're gonna just simply define a function in C++. Like so, return a plus b. And let me do lsp stop so that we don't get spammed. And so there we go. And then I will do my just make. I already ran cmake before. So when you run make, it will generate this file. So example cpython something something something, which is a shared object. And this shared object you can directly import it in Python. So if I do Python and now I do import example, it will work because it just literally loaded this file. And so now I can do example add 1, 2, like so, and it called my C++ function, which was exposed to Python. And that's freaking awesome that with so little code I was able to do this whole thing. So yeah, very quickly I can show you that you can add documentation to your function like so, just by providing a string to numbers like so. And now if we, I'm gonna use this, which is just a shortcut to build it and then run Python. And as soon as I as I run the Python interpreter, it will import example and print the help of our module. This is just to be a bit faster. And so you can see that it added the docstring here. You can also add docstring for your whole module, my module like so. Up. The syntax is a bit strange, but it's okay. You can specify the names of the arguments of your function by doing so we need to first create an alias to the namespace pybind11, just because we're going to type it a lot. And then you can say arg, and then you can say that the first argument is named A, and the second argument is named B. Unfortunately, pybind11 cannot infer that itself, but now we will see that the documentation of our function should be better. Oh yeah, it did work. It's just that it was confusing me with this and this, but here actually we can see that it does have the correct types and the correct names, because before I just used like a boilerplate arguments, so arg0 and arg1. And so the difference now is that we can just use add, and it's the same as before, but what we can do now in addition is that we can use named parameters like so. So yeah, in C++ we can have default values for our arguments. So let's just say by default b is 42. And unfortunately, pybind11 cannot know this default value, so you have to unfortunately repeat it. So here we have to say this equal 42 as well. Like so. And so if I recompile, we will see it. So example add, and let's just do I don't know, 4. Then you can see that yeah, the value of b was the default one. So yeah, this is only brushing the surface because there is something very nice is that PyBind 11 integrates with all the standard library types. So let me just fetch a little example that I have. So here in this case, we can see that this function uses std vector, std string, std map, and yeah, that's it. But there is all kinds of integration with the standard library of C++. So obviously a vector will map to a Python list, a string will map to a str of Python, and an std map will map to a dictionary in Python. And so if I just add this function, like so, let's just do keys. Yeah, I didn't say what the function does, but it's very simple. It takes a dictionary and returns a list, well, a vector of its keys. So very simple stuff. Let's just remove the documentation, just for the sake of brevity. Up, 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 up. Let's compile this to show you that it works. So we can say example keys and then pass a dictionary of A1, B2, like so, and we can see that it works flawlessly, which is very nice because I didn't have to do any conversions from Python to C++ myself. It just did everything for me, which is amazing. So yeah, function overload is also supported. So if all of a sudden I decide that this should have a float overload, like so, I can have this, and to distinguish them, we should, I don't know, I'll do 3 times something to show that they are different. The only thing you need to do, let's just simplify this, is that you need to use the py overload cast, and then you need to specify the types of your arguments. So int in this case, do I specify the address? Yes, I do. And so we can have this, like so, and then we can have a second one where we replace the ints by floats, and this should still work. Yes, so example, let's do add 1 and 2, and we can see that it's the int overload, and if I specify one of the member as a float, we should see that it did 3 times 1 plus 2. Yes, okay, that works. I should have modified the first one to make it more obvious, but you see my point. The overload works. Next, let's do enums. So let's remove this. Let's remove this. This as well. And let's just have a color enumeration. Just red, green, blue, nothing fancy. And you'll notice it's just a C enum. It's not a C++ enum class. And so what you can do is declare your enum in Python like this. Unfortunately, for enumerations, you do have to list every single member of your enumeration manually. So, but you declare it like so by native enum. So what native enum is literally the standard library enum type of Python. So yeah, the enum module in Python, just so that it's compatible with the rest of the ecosystem. You need to specify again the type name and the enum for inheritance, I guess. And then there is a bit of boilerplate. But my point is that when you do that, you have well, we already saw it in the help, but you can have your color, and you can have color red, like so, and you can assign it, and it's your enum, and you have it in Python. You can change it, and so on and so on. So yeah, this also works with enum class. It's exactly the same, except that obviously you need to specify the color for each of the types, but it will be exactly the same. Oh yeah, by the way, you need to include this header for this to work. But yeah, it will be the same. You can still do this. Yeah, so that's it for enums. Next, we can quickly see that it works for structs. So again, let me copy paste my little example. I have a class foo, which has a name and it can scream its name. So nothing crazy. You can see this here. The way you do this in PyBind 11, you do a py class to define a class. You specify the type of your class, foo in our case. You specify the module, the name. I'm guessing this is the Python name, maybe. That would make sense. So you can export your class as something, another name, maybe. And then you can define, and you do need to define each method. It cannot like guess the methods for you. So let's first, there's a special thing for the constructor. It's PyInit, and you need to specify the types of the arguments of your constructor. But besides that, the constructor is just like any other method. Here as well, it will be scream like so, and it will be foo scream, because methods are just functions. Well, that's why they're called member functions, actually. And so we will see that if I do this, yeah, it's not stream. I don't know why I said stream there. It's scream. So yeah, we have you can see the documentation of our foo object in Python, and you can say foo, f is equal to foo, and it will be my name because I'm a very narcissistic person, and that didn't work. So, oh yeah, because it's example foo, like so. We can see that it's an object, that it exists, and we can call the method scream on it, and it will scream its name. So, and yeah, again, all of that, all the std string conversions, all the constructor calling was done for us by the PyBind 11 library, which is very nice. You can also have getters and setters for your object. So you notice that I have a name attribute here, but if I try to access it in Python, that will not work. So what you need to do is call def read-only. So this will create, well, a read-only attribute. So like so, and you need to specify foo name like this. And now if I try to access fname, it will work. If I try to assign it to something else, it will not work. But then there is this the other one, another one, which is called def read writes. So exactly the same, except that now we will be able to overwrite it. Like so, and then now if I try to overwrite its name, it works. And to prove to you that it actually renamed it, it does work. So yeah, I'm going over this a bit quickly, but this is my last example, just to showcase a bit the library. Let's remove this struct. Let's create this function. So this is just to showcase a bit how exceptions are done. PyBind 11 will also auto-convert most of the standard exceptions of C++. So if we just do def will throw like so, and we remove that like so, and then we do example will throw. You can see that it converted my std runtime error into the Python version of that. So yeah, PyBind 11 is very powerful. This is the end of my example, but I suggest that if you're interested in PyBind 11, you should go on their documentation and give it a try, because it's a very, very complete library. Let me see if I can showcase some other stuff. For example, like you can do stuff with templates as well. So you can have one template function and then specify yeah, which versions, which template specification you're going to use, and have multiple defined for that. The exceptions I think I already showed you, but obviously they have more mappings to different exceptions, and you can do other kinds of fancy stuff with exceptions that's not very interesting. They support inheritance, so if I can find it, multiple inheritance. So yeah, well, they have very complex inheritance, but they also have just normal inheritance. You can, something I forgot to mention, well, that's not an example about that, but you can have just lambda functions as defines. So you could just say def value and then have a lambda function here, and it would just work. You can, they have something about implicit conversions apparently, but that I didn't look at yet. I think an interesting one was static properties. So both Python and C++ have static members and static functions, and you can have those. It's the same as what I did before, except you need to say that something is static. In Python, you have also the property decorator. They also have this somewhere in this documentation. Brace initialization, non-public destructor. Yeah, they have all kinds of stuff with inheritance. You can even, apparently, I've never tried this, but you can have a Python interpreter in your C++ function, which is, I guess, kind of cool if you have like the bulk of your application is actually in C++. Like the executable you're running is in C++, but there is some, I don't know, Python scripts made by some other members of your team which are more familiar with Python, and they just need to inject a bit of Python code into your application. This is usually done with something like Lua, but you can also do it with Python, evidently. So yeah, a very cool thing, which I hope, yes, in the type conversion. So of course I showed you already that there is most of the don't they have a table? There is most of the standard library in there, so std map, std vector, and so on and so on. But they also have built-in compatibility with the matrices library. So NumPy is supported, Eigen is supported. There is also std chrono, but that's a bit something else. But that's also nice to have like the date time and so on conversions. So yeah, I guess right now I'm kind of rambling about the library. It's not very interesting, so I think I'll cut the video. Maybe I can find something else that is interesting. But yeah, they also have stuff where you can literally push C++ memory to Python, but attach a little context to it to know when to let the Python interpreter know that when it runs out of reference for this thing, it needs to free it. I think it was called capsule. Capsule. Well, okay, that's capsule. Yeah, I can't find it, but this is a way you can add some kind of destructor behavior to raw C++ memory, which is kind of nice to avoid copies. So anyway, this is all for this video. I think it has been long enough. I hope you enjoyed it, and I think in the next one I will do the same thing but for Node.js bindings, which is unfortunately much less nice but still possible. So I'll do a video about that. Hope you enjoyed it, and see you in the next one.